really quite an honor. I didn't know I was the first one to be invited. That's really lovely. Well, I want to start with a question. And my question is, what is the biggest question facing the human race today? Well, probably many people would pick something like, how do we achieve world peace? Or how do we stop global warming? But the fact is that with regard to issues like this, we already know a lot of things that could be done, both politically and technologically, that would be hugely helpful in moving toward a peaceful, sustainable world. But we're not doing them. So, the really biggest question is this: what can possibly motivate people around the world to want to do what must be done? Global problems can't be solved by any group, any country, or any known political or religious system. And the reason is that they operate on a size scale that's outside our experience and intuition. They require a new way of thinking. And I'm here to suggest one. We have an opportunity today that is as huge as our problems, that hardly anyone knows about, that's coming from a place that nobody would have expected and that never existed before. The opportunity is coming from cosmology, which is a branch of astrophysics that studies the universe as a whole, as a single being with a single evolutionary history. In the last couple of decades, cosmologists have discovered the hidden nature of the universe. What is it made of? How big is it? How does it operate? And how do we humans fit in? They're giving us the first origin story in the history of the world that was ever based on evidence. And the opportunity is that now we can understand our species in its full cosmic context. We can understand what is really at stake on planet Earth in our time. So by the end of this talk, I hope you will see that you and all of us fit into the modern picture of the universe in amazing ways, and that if we could begin to think and act from this new cosmic perspective, we could find the motivation to deal with our worst global problems. I'll come to the role of women in this soon. But first of all, let me just mention what I mean by saying, how do we fit into the universe? Well, many secular people assume that we are living on an average planet of an average star in a universe where no place is different from any other, and the way we fit in is we're just insignificant motes in a possibly endless universe. But this picture is completely wrong. It's based on 17th century science. It turns out that we humans are extraordinary. We have an extraordinary planet, and even our sun is an extraordinary star for its type. The way that we fit into the universe is we are central. We're not geographically in the middle. There is no middle to an expanding universe, but it turns out that we intelligent beings are central to the principles that underlie the modern picture of the universe. And this isn't anthropocentric, it's physics. This is telling us what we really are. So I want to explain 3 ways of the 8 that we've discovered so far that we humans are either central or special to the modern picture of the universe. We are at the midpoint of all possible sizes, our bodies, that is. We're made of the rarest material in the universe, which is stardust, and we're living in the middle of time on multiple size scales. Now, I realize that all this may seem very counterintuitive, and you may be pretty skeptical about the whole thing, but it's really important that we not allow our earthbound intuition to enslave us, because if we do, we'll never be able to see the real universe. So I'm going to explain each of these ways with a picture. And, you know, I've got 20 minutes here, so I'm going to zip very fast through some scientific concepts. And if you don't get it all, it's fine. You're normal. Okay. So we are at the middle of all possible sizes, okay? So here are all the sizes in the universe. This is a picture of the whole universe from the point of view of size. And the serpent swallowing its tail represents all of the sizes because the head of the serpent represents the size of the entire visible universe. The tip of the tail represents the smallest size that physics allows, the Planck length. And if you notice, you will see that we humans are right in the middle. So if anybody ever tells you we're just insignificant motes, you can tell them, no, we are not. We are at the middle of all possible sizes. Now, really quickly, I'm going to take you on a trip from the largest size that we represent. Oh, that woke you up. And the arrow on the serpent will point to the size scale that we're actually looking at. We've now come down into the galaxy. We're coming down to the size of our solar system. There's the sun just past us. We're coming down to the Earth, to the size of mountains, people, actually children, single-celled creatures, the DNA inside them, the individual atoms that those DNA molecules are made of, and now the nucleus of the atom. Okay, way number 2 that we are central. We are made of the rarest material in the universe, stardust. We are jewels. Stardust is the atoms that are created inside stars and then they get blown out into the universe when those stars supernova. Now, people used to think that everything was made of atoms. Not true. It turns out that 95% of the universe is not made of atoms. What we can see is less than half of 1% of what's actually out there. The universe is actually mostly made of 2 invisible things called dark matter and dark energy. So we can call this the double dark theory. So let's visualize this. Imagine that the entire universe is an ocean of dark energy. And on that ocean, there sail billions of ghostly ships made of dark matter. And at the tips of the tallest masts of the largest ships are tiny little beacons of light. And those beacons of light are what we call galaxies. We can't see the ships. We can't see the ocean. But now we know they're there through the double dark theory. Dark matter is pretty weird stuff. It's not made of atoms or the parts of atoms. It's very mysterious. And here in Europe, they're trying to actually discover it at the Large Hadron Collider. But dark matter is 25% of the contents of the universe. Stardust is 1/100th of 1% of the contents of the universe. Dark energy is 70%, and that's the energy that's making the universe expand faster and faster. I wonder if I could lower the lights in the front. I want to show you 2 very brief videos. First, we're going to take a little trip. And everything in this video, we're heading toward Orion from Earth. Everything in this video is a picture from Hubble Space Telescope arranged in the computer in 3 dimensions. And all these stars have actually been mapped. These are not random dots. Now, as we head out away from our planet, you'll see that this is the nebula in Orion. And the next interesting object we see is something called the Horsehead Nebula. And when we pass there, we're now 1,500 light years from Earth. We're going to take this trip through our galaxy. We're going to come out of the galaxy and then go across space to the nearest large cluster of galaxies. We're still inside the galaxy. You can see a lot of dust is covering most of the stars. And that dust is the stardust. That's what eventually comes together to make us and planets like ours. This is a supernova remnant. You can see the pulsar in the middle still vibrating. Now, to see what the galaxy really looks like, let's rise up and out of the disk and see what a gorgeous galaxy like our own looks like. Several 100 billion stars. As we recede away from the Milky Way and its companion galaxies. Every dot you see here is a galaxy of billions or hundreds of billions of stars. That's our nearest large companion, Andromeda, and the small one in the foreground that we're about to go through is the Triangulum. As we pass through this gas cloud in the Triangulum galaxy, we're 2 million light years from home. And what I want you to notice here is that galaxies are not just scattered randomly in space. They lie along long filaments, and where the filaments intersect, that's where the clusters of galaxies form. In the lower left, you can see the cluster that we're actually heading for, the Virgo cluster, but we're not going to go directly there. We're going to come around and ride down one of those filaments to the center of the Virgo cluster. Incidentally, this and many other videos you can see on our website. Now we're coming down the filament, riding toward the cluster, and in the middle, our voyage will end at a galaxy, a huge galaxy with a black hole at the center that weighs 4 billion times the mass of the sun. Now all this is visible. This is all observations made with a telescope. But the next video I'm going to show you is the invisible dark matter, which obviously, since you can't see it, there's only one way to show it, and that's through supercomputer simulation. Before we get there, I just want to show you that this is the scale. The visible part of our galaxy is this little part in the middle. It's about 100,000 light years across. But the dark matter halo is all of this, 1.5 million light years across. So the vast amount of the galaxy is really dark matter. Now we're going to zoom in here and put this in its context. And this is the cosmic web. You are looking at the structure of the universe across 1 billion light years. And you can see why the galaxies are laid out in filaments, because this is the dark matter, and it has all of these filaments. And inside every tiny, tiny dot here is a galaxy. So we're going to zoom into a little cube of 100 million light years, and this is the dark matter. Every dot here would be hosting a huge galaxy deep inside it, just as you saw before. Dark matter pulls widely dispersed atoms together into the centers of galaxies and concentrates them so that they can interact and create chemistry and evolve and create planets and life. Dark matter, in some sense, cradles each galaxy in invisible hands that protect the galaxy from the storm of dark energy that is tearing space apart outside. We are made of stardust, but stardust would never have existed without dark energy and dark matter. So the third way that we're central is that we are living at a cosmically pivotal moment. Now, clearly I don't have time to explain all the ways that we're living. I'm just going to briefly mention that this is the peak moment in the history of the universe for astronomical observation. There will never be this many galaxies visible again. This is also the midpoint of the existence of our solar system, the midpoint of the best period on Earth for creatures like us. And here's the most important, and the only one I'm going to talk about. It's the end of the exponential expansion of the human impact on the Earth. This graph shows time here and the amount of carbon dioxide in our atmosphere. And as you can see, the blue line shows you that for the past 2,000 years, the amount of carbon dioxide in the atmosphere has been pretty much stable, and you can take that line back 800,000 years, it's still about the same. But since 1800, humans have been burning fossil fuel. And since around 1800, the amount of carbon dioxide in the atmosphere has doubled every 30 years. And you can see now that it's shooting straight up almost. And if this continues for the next century, this is what it would look like. Now, clearly, this would be utterly catastrophic for Earth. So the amount of carbon dioxide and many other exponential increases in our impact on the Earth are going to have to stop very soon. And that makes our time a pivotal moment for our entire species. It's great that women are on the rise in power, in business, and politics. But let me warn you that the rules of the game are changing much faster than most people realize or want to realize. So now the question is, how can we help people grasp the immense but fleeting power of our pivotal moment to make the changes that could really lead to a sustainable Earth? You can't just tell people facts, especially scary facts. That just makes them want to run away. But people can change. How do they do it? People change from discovering a big new identity that is available to them, that could make their lives more meaningful and exciting, that connect them to people they want to be associated with. Under these circumstances, people can change very quickly. In fact, this is how we fall in love. This is how alcoholics and addicts can recover. This is the basis of all spiritual awakenings. It doesn't belong to religion. This is an ability that every human being has to change through a new identity. So I want to try a little thought experiment about identity. So probably this would be easier if you just close your eyes. I want you to imagine that you look in a mirror and you see yourself as you appear right now. Your body is solid, your heart is pumping, but the process that got you here is simply not part of your consciousness. You're listening to the latest music, buying the latest improved products, believing the latest media interpretation of the world around you. In some sense, when we do this, we're like a computer with hormones. But now, what I'd like you to do is imagine instead that you look into the mirror, but this time you see past the momentary you of today, back to the you of years ago, back to the child that you were, then the toddler. In fact, send your consciousness backward through time at lightning speed, down past your parents and grandparents, past the countless generations that came before them, your ancestors roaming from continent to continent, your primate ancestors, down through all the animals that preceded them, back to the earliest life, to the first cell, and down into the chemicals that made it possible, down into the molten planet and the forming solar system. Send your consciousness back to the birth of your carbon and oxygen and iron atoms in exploding stars far across the galaxy. Back to the formation of the galaxy itself deep inside a halo of dark matter. And back through the universal expansion to the creation of your elementary particles that you are made of at this very moment in the Big Bang. This isn't fantasy, this is science. We are all this. And what we need to understand is that who we are is the sum total of our history, and how far back we understand that history, how much of our identity we claim is up to us. No one had this choice before because our generation is the first to know our real origin story, and the first, I think, to realize that this story could be our species' salvation. The key to visualizing a long-term future may be to grasp the immensity of our cosmic past. So I want to come back to the question we asked in the beginning: what could possibly motivate people around the world to want to do what must be done? In his last book, the great mythologist Joseph Campbell wrote, "The old gods are dead or dying, and people everywhere are searching, asking what is the new mythology to be, the mythology of this unified earth as of one harmonious being." When Campbell died in 1987, there was no answer to his question, but today there is. The new cosmology is not a Western creation. It has been put together by scientists from many countries and many religions, all working according to the same scientific standards. This cosmology can become the foundation of a modern mythology for our planet, something that can unite us with a vision of a multi-million-year future. We need to wake up to what Václav Havel so poetically called the revitalized authority of the universe. Women around the world choose to dedicate far more of their own disposable resources to their children's well-being than men do. So it may be up to us to become the rational, non-testosterone-driven, thoughtful, and caring leaders that Dr. Coates talked about yesterday. Our species is central to the cosmos and central to the future of Earth. And because this is a pivotal moment for our whole species, those of us who are alive today may be the most significant generations of humans ever. When enough of us claim this big cosmic identity, that will transform the world. So think cosmically, act globally, eat locally. Thank you.